Hello. Uh, First of all, just a small explanation of why there were no new videos in the channel for a while now. I have been traveling a little bit, taking a break from work. So the last 20 days or so, I haven't been able to post any videos. Um, anyway, I'll be starting resuming. I'll be resuming the work shortly. So uh, new videos will start appearing on the channel soon. Today, I'd like to clarify something that I gave as assignment to my students. This is the question paper for physics ICSE 2020. And I had given this paper as an assignment for some of my students. And in section 2, question number 5C, some students had expressed a doubt about um, the question and what the answer could be. In particular, the second one, the Roman number 2, they had a question about this one. That is a block and tackle system of pulleys has a velocity ratio of 4. Draw a label diagram of the system indicating the point of application, direction of load and effort. That part was done easily. What will be the velocity ratio? What will be its velocity ratio if the weight of the movable block is doubled? So there were some doubts and questions. So let me try and answer that question. Um, we can answer this question theoretically from our understanding of what the velocity ratio is. So the velocity ratio we know is the distance moved by the effort arm divided by the distance moved by the load arm, basically the ratio between the two. Now, if you take the block and tackle system, let me just draw roughly the kind of block and tackle system that we are talking about. It's always a good idea to make a diagram. Of course, the first part of the question already asks you to make a diagram, so you can use the same diagram for reference. But I'm just going to draw a quick one. And apologies for any errors in the drawing. I have a new graphics tablet and I haven't yet mastered my control over it. So it's a bit messy still. Okay, not bad, I think. Okay. So the question over here is for the lower block, this lower block over here, if the load is going to be doubled, what will happen to the velocity ratio? Okay. Now, it's a simple logical thing. That is, if the load gets doubled for a machine, the effort that has to be applied in order to support the load should also proportionately increase, right? So the effort is also going to be doubled. So it's that part of it has to be intuitively seen, that you have to understand intuitively that when the load doubles, the effort will also have to double. Otherwise, if the effort doesn't double, then the entire load block is going to just fall down. Okay, so once that is understood, then it's easy to see that the velocity ratio will not change, because whatever factor the load has got doubled increased by, sorry, the effort is also going to be increased by the same factor. All right. So therefore, the velocity ratio will remain exactly the same. So that can be one way of looking at the answer to this question. You can also look at it sort of to say logically from the working of it. So what we are talking about in terms of the distances moved over here is that, say you pull the rope over here by some distance x, right? The load is going to go up by some distance. In this case, since the efficiency of the block and tackle system, we assume it to be roughly equal to 1. if the velocity ratio is 1, then if the velocity ratio is given as 4, then the mechanical ratio is also going to be 4. So that I'm just going to put it over here as another equation. Eta is equal to ma upon Vr, right? So if eta is approximately equal to 1, then ma is equal to Vr, right? So if the if the velocity ratio is given as 4, then the mechanical advantage is 4. That means that the distance that the load is going to go up by, right, when you pull this by a factor of x, would have to be x by 4. The reason being that if you look at the work input, or the, let's say, the work done at the effort side, it has to be equal to the work done at the load side. So if E times X has to be equal to the load times X by 4. Right? Only then the work done on both sides are going to be equal, because effort is going to be 4 times that of, load is going to be 4 times that of effort. So that's another way in which you can work out that the velocity ratio is going to remain exactly the same. So these are roughly the two arguments to know why the velocity ratio does not change if you double the load. Of course, this particular question does not expect you to answer it in detail. You don't have to give the arguments. But just remember that if you are asked such a question, that is, there is a given velocity ratio, and they say, well, if the load doubles or the load increases, then what happens to the velocity ratio? You can argue that the velocity ratio is the one factor that will not change.